Okay, so as promised, now we're going to look at a recursive definition of a particular type of rooted tree called a full binary tree. So again, we begin by starting simply with a root as the basis step in the definition of these full binary trees. And now the difference between rooted trees and binary trees is that in binary trees we take exactly two trees formed in a previous step and add a root to the bottom and connecting that root to each of the roots of the different trees that we have previously defined. So in step one, we can simply add two copies of our tree formed at the basis step, simply our root, and add a root connecting that root with each of the roots of the different trees previously defined. At the next step, we can take any two of the previously defined full binary trees, so simply a root or the full binary tree constructed at step one, and add a root connected to each of the roots of those two trees. And we can add these in any order, so we could add this one to the right and this one to the left and connect them with a root, or we could take two copies of this full binary tree and connect them with a single root at the top. And then at subsequent steps, we can take any two copies of any of the previously defined trees and continue to add them with a common root at the top. And so our trees will grow downward in a similar fashion. So what does this look like recursively? So again, at the basis step, we simply have a tree consisting of a single vertex R, which is the root. And the recursive step tells us that if we have two previously defined full binary trees, T1 and T2, we form a full binary tree T1.T2 consisting of a root R together with edges connecting each of the roots of the subtree T1 and T2. So we take these two existing trees, T1 and T2, add a root to them, and add edges between this root and the root of T1 and T2, respectively. So that is a recursive definition of full binary trees. And next we're going to look at the definition of structural induction and then apply structural induction to prove properties about full binary trees.